Okay, pre-calculus students, we're still in day 1, and we're moving on to, on page 2, the domain of the square root of a quadratic function. So if you think of a quadratic function all by itself, you know that the shape of that function's a parabola. And if you think of the domain of a square root, you know you can only take the square root of the positive values. So there will be some values, if you think about your x and y axes, some values where the parabola will have positive y's, and some values where the parabola will have negative y's. So the idea behind finding the domain is that we have to figure out when will the quadratic equation have a positive result so that we can apply the square root. So there's a method for this, and in this method we factor and we find the key points. So the procedure is right here. You set the quadratic equal to 0. That's just the inside part. So let's do that first. X squared minus x minus 6 equals 0. And then in step 2, we're going to factor and find key points on the number line. So I need to find two numbers that multiply to negative 6 and add to negative 1. And those numbers are negative 3 and positive 2. So my factors are x minus 3 and x plus 2. If I have two factors that multiply to 0, one of those factors has to equal 0. So I set them equal to 0. I get x equals 3. And this one gives me x equals negative 2. So you set up a number line with those key points on it. Alright, so negative 2 will be on the left, and positive 3 will be on the right. Alright, so next, we're going to test points. So I need to test a point in each section of my number line. So that means 3 sections, I'm going to test 3 points. So here's my test over here. X is the input, and then I want to know the sign of my answer. I want to know if it's positive or negative. So over here I could choose any number less than negative 2. I'm going to choose negative 3. In here, any number between negative 2 and 3, so I'm going to choose 0. And any number bigger than 3, so I'm going to choose 4. So if I put negative 3 in for x in both factors, I would have negative 3 minus 3, negative 3 plus 2. And I don't need to know the answer, I just need to know if it's positive or negative. So this is a negative times a negative, which is positive. When I plug in the 0, 0 minus 3, 0 plus 2, negative times positive, that gives me a negative answer. And then for the 4, I have 4 minus 3 and 4 plus 2. So positive times positive gives me positive. So what that tells me is, in this section, all my answers are going to be positive. That's from here. In this section, all my answers are going to be negative. And in this section, all my answers are going to be positive. I can only take the square root of the positives, so I want in my domain these numbers and these numbers. So my domain starts at negative infinity and it goes up to negative 2. I can take the square root of 0, that's what I'll get if I plug negative 2 in, so I want to include the negative 2. And then, not these numbers, but go and include the 3, and go up to infinity. And this is your domain for example 1. Alright, in example 2 we have to factor 1 minus x squared. So to factor 1 minus x squared, you need to remember the special pattern that if you have a squared minus b squared, that factors to a minus b times a plus b. So 1 is the square of 1, so this is going to be 1 minus x times 1 plus x. And I need to set my factors equal to 0. So when I do that, if I have 1 minus x equals 0, that gives me x equals 1. And if I have 1 plus x equals 0, that gives me x equals negative 1. And those are going to be my key points on my number line. So draw your number line. And you need a negative 1 and positive 1. So now we're going to test. Put in x values, find the sign of the answers. Alright, a number that is smaller than negative 1 is negative 2. A number between negative 1 and 1 is 0. And a number greater than 1 is 2. Okay, plug in negative 2. I have 1 minus negative 2. So 1 minus negative 2 is the same as 1 plus 2. And then I have 1 plus negative 2. Oops. So this is a positive times a negative, which is going to give me a negative result. When I plug in 0, I have 1 minus 0, 1 plus 0. Positive and positive, that gives me a positive result. And when I plug in 2, I have 1 minus 2, 1 plus 2. So negative times positive is negative. So on my number line, this section gives me a negative result, this section gives me a positive result, and this section gives me a negative result. So my domain is just the numbers between negative 1 and 1. Alright, so these are the practice problems. They are similar to examples 1 and 2, so you should pause the video and try them before checking to see if you did it right. Okay, in number 1, you can see we have the difference of squares again, so we're going to use our a squared minus b squared pattern. X squared minus 9, 9 is the square of 3, so when I'm factoring this, I'm thinking x squared minus 3 squared. And so my factors are x minus 3, x plus 3 equals 0. And when I set each factor equal to 0, I get x equals 3 and x equals negative 3. So on your number line, put your key points. Negative 3, positive 3. And then we need to test a number in each section. So x and the sign. Alright, a number that's smaller than negative 3, I'm going to put negative 4. A number between these two, I'll put 0. And a number greater than 3, I'll put positive 4. And plug those into your factors. So negative 4 minus 3 and negative 4 plus 3. That's a negative times a negative, which is a positive. 0 minus 3, 0 plus 3. Negative times positive is negative. And 4 minus 3, 4 plus 3. Positive times positive is positive. So this section is positive, negative, positive. So we want to include the answers over here and over here. Domain is negative infinity to negative 3 and 3 to infinity. Alright. In problem 2, we need to factor, we need to find two numbers that multiply to negative 10 and add to negative 3. And those numbers are negative 5 and 2. So let's draw a line here. And I have x minus 5 times x plus 2. And that equals 0. So I set each factor equal to 0, and I get x equals 5 and x equals negative 2. Negative 2 and 5. Alright, now to test a point in each section, I have x and the sign of the answer. So smaller than negative 2, I have negative 3. In between is 0, and bigger than 5, I have 6. Plug them into your factors. Negative 3 minus 5, negative 3 plus 2. That gives me negative times negative, which is positive. So this section here is positive. Okay, 0 minus 5. And 0 plus 2. Negative times positive equals negative. This section's negative. 6 minus 5. 6 plus 2. Those are both positive. So positive times positive is positive. So my answers are here and here. Negative infinity to negative 2. And 5 to infinity. Okay, so now we're going to move on and combine the restrictions of radical and rational equations. So remember that radical equations, those would be like square roots. You can only take the square roots of the positive values. And rational equations, your denominator cannot equal 0. So we have to combine those two ideas. Okay, in the first one, because it's rational, the denominator cannot equal 0. And because it's radical, the radicand, that's the part underneath the square root, has to be greater than or equal to 0, because you can't do the square root of the negative. So if you put these two ideas together, greater than or equal to 0, but not equal to 0, you get just greater than 0. So the part underneath the square root, the 3x minus 1, has to be greater than 0. So add 1 to both sides, 3x has to be greater than 1, and divide by 3, x has to be greater than 1/3. And sometimes you'll see the restriction on the domain just written like this, or sometimes you'll see it written in interval notation, which would be starting at 1/3, but not including it because there's no equal, and going to infinity. Alright, in problem 2, our square root is in a different place than our denominator. So we still have two things, it's just a slightly different situation. Our rational is that x squared minus 2, or x squared minus 4, cannot equal 0. And our radical is that x plus 4, which is the radicand, has to be greater than or equal to 0. So two different places. So let's see, let's start with the rational part. In the rational part, if I say x squared minus 4 cannot equal 0, and I factor it, x plus 2 times x minus 2 cannot equal 0, then I can say x cannot equal negative 2, and x cannot equal positive 2. All of that together. Alright, so in the rational part, or sorry, in the radical part, I have x plus 4 is greater than 0, so that means, let's write it again, greater than or equal to 0. Subtract the 4, x is greater than or equal to negative 4. So if you want to think about this on a number line, let's see, here's 0, 1, 2, there's negative 2, there's negative 4, and there's positive 2. So x is going to be greater than or equal to negative 4, so there, like that, except x cannot equal negative 2, so we have to leave those values out, and x cannot equal positive 2, so we have to use those values out. So really our domain has 3 pieces, this piece, and this piece. And so if we were going to write this in interval notation, we would say domain starts at negative 4, it goes up to negative 2, but you don't want to include it because x cannot equal negative 2. So use a parentheses. Then pick up right after negative 2 again, so another parentheses, and go to positive 2. And then pick up right after 2 and go to infinity. Okay, and the third one is another example where you have rational and radical. So for the rational part, just the denominator cannot equal 0. So x plus 2 cannot equal 0, and so x cannot equal negative 2. For the radical part, the part underneath the square root, 5 minus x, has to be greater than or equal to 0. So subtract the 5, and you have negative x is greater than or equal to negative 5. When you divide by negative 1, remember that that flips your inequality, so x is less than or equal to 5. So on your number line, if you have 0, 1, 2, 3, 4, 5, and negative 2, less than or equal to 5, except not negative 2. So we want to write this in 2 different pieces. We're going to say negative infinity up to negative 2. And then 2 to 5. We want to include the 5 because it's less than or equal to 5. But we did not want to include the negative 2. Oops, that's a negative 2. Because x cannot equal negative 2. Alright, we're going to turn the page and we're going to talk about zeros and intercepts. Okay, to find zeros on a graph, and zeros are also called x-intercepts. To find them, you want to set the y equal to 0. To find y-intercepts, those are over here, you're going to set the x equal to 0. So in example 1, we need to find a y-intercept. So we're going to set the x equal to 0. So I have 0 squared plus 7 times 0 plus 6. So my y-intercept is 6, and that point is 0, 6. To find the zeros, I set the y equal to 0. That's over here. So let's use this space. 0 equals x squared plus 7x plus 6. You need to find 2 numbers that multiply to 6 and add to 7. So 0 equals x plus 6 times x plus 1. And then set your factors equal to 0. You get x equals negative 6, x equals negative 1. So my zeros are negative 6, 0, and negative 1, 0. F of 2 is what you get when you plug 2 in for your x's. So for f of 2, I have 2 squared plus 7 times 2 plus 6, and I get 24. And the last one says f of x equals negative 6, find x. So you would put negative 6 over here on the y side. So negative 6 equals x squared plus 7x plus 6. To solve a quadratic, you need one side to be 0, so I'm going to add 6 to both sides to get 0 equals x squared plus 7x plus 6, nope, plus 12, because I have to add the 6 to the 6. And now I need two numbers that multiply to 12 and add to 7. Those are 3 and 4. So 0 equals x plus 3 times x plus 4. And then my solutions to this one are negative 3 and negative 4. Alright, example 2. To find my y-intercept, I'm going to make my x's 0. So 0 plus 6, 2 times 0 minus 4. So these are both 0. I have 6 over negative 4, which simplifies to negative 3 over 2. So my y-intercept is 0, negative 3/2. Alright, to find my zeros, I make my y0. 0 equals x plus 6 over 2x minus 4. However, when a fraction equals 0, it's really just the top part that needs to be 0, because 0 divided by anything is 0. So you can also write 0 equals x plus 6, and if you subtract 6 from both sides, you get x equals negative 6. So negative 6 gives me an answer of 0. F of 1 is what I get when I plug 1 into the equation for x. So f of 1 is going to be 1 plus 6 over 2 times 1 minus 4. So I get 7 over negative 2. So negative 7 over 2. And f of x equals 3. So that happens when I put the answer as 3. So 3 equals x plus 6 over 2x minus 4. So I could think of this as cross multiplying. So 3 over 1. And so this is x plus 6 times 1. And 3 times 2x minus 4. 3 times 2x is 6x. 3 times minus 4 is minus 12. So you need to get your x's to one side. So subtract this x, and that makes 5x over here. And now solve for x. So add 12 to both sides. I get 17 equals 5x. And x is going to be 17 over 5. Did I do that wrong? Nope, that's 18, isn't it? 18. Alright, and in example 3, we're going to plug 0 in for the x. So let's see. Square root 2 times 0 minus 4. I get the square root of negative 4, which is not real. So that's not something we can graph, and there is no y-intercept. Alright, to find the zeros, I want the answer to be 0. So 0 equals the square root of 2x minus 4. And if you square both sides, you get 0 equals 2x minus 4. So add 4 to both sides. 4 equals 2x, and x equals 2. So you have a 0 of 2. To find f of 3, Let's see, choose a new color. Plug the 3 in. So square root 2 times 3 minus 4 gives you square root of 2. So f of 3 equals root 2. And if f of x equals 5, find x. So put a 5 over here. 5 equals square root of 2x minus 4. Square both sides, so 25 equals 2x minus 4. And 29 equals 2x. X equals 29 over 2. Okay, so I'm going to stop the second video here, and before you start the next video, try these 2 practice problems to see if you get that, and then we'll move on to the last section.